Okay, we're going to start our study of mechanics by thinking about displacement and velocity. So, let's think, what do we mean by this? Let's think about the nursery rhyme about the Grand Old Duke of York. Now, the Grand Old Duke of York, he had 10,000 men. He marched them up to the top of the hill. I'm only drawing the Grand Old Duke of York, I'm not with 10,000 men. And he marched them down again. Let's imagine that the distance from the bottom of the hill to the top of the hill is 100 metres. So the Grand Old Duke of York and his 10,000 men go 100 metres up the hill and then 100 metres down the hill. The total distance travelled is 200 metres. Now let's think of displacement. Displacement is a vector. A vector is a number which has a magnitude and a direction. So if our Grand Old Duke of York goes up 100 metres and then down in the opposite direction 100 metres, his displacement is 100. He's gone up 100, but then he's gone in the opposite direction, so it's negative 100 metres. So his displacement is 100 plus minus 100, which equals 0. He's back to the point in which he started. When we think of a vector, we always need to define a point of origin. For example, say we come off the bus here. This is a bus stop. This is our point of origin. And our home is along the path and then up our garden path to our home. Here's our home. We go along this direction. Say we go in this direction for 10 metres. Then we go up to our front door. Say that's 2 metres. The total distance we've travelled is 12 metres. But our displacement is different. We take these two vectors, 10, and then add the 2, and then when we get this vector here, this is our displacement. And as this is a right angled triangle, we can use Pythagoras to work it out. So our displacement is going to be the square root of 10 squared plus 2 squared, so square root of 104, which is just calculate that. Square root 104 is 10.2 meters. So that would be our displacement. And we think of it as the distance, but in relation to the origin where we started off. Now, let's think about speed. Speed is the distance covered over time taken. So we can think of it, Now, obviously, when you're driving in a car, you're not going at a constant speed, so we would often think of average speed equals the total distance covered over the total time taken. Now this speed is a scalar, just in the same way as distance is a scalar. Velocity is its vector equivalent. Velocity is the change in displacement over the total time taken. And this is a vector. And again, the vector needs to, we need to define the point of origin. So, say we have a car, this is point origin, and we have a little car. If it goes in this direction, we can call that the positive direction, positive velocity. But if it goes in this direction, it can have a negative velocity. And this is something that is not always intuitive, because the car is still travelling, it's just going in the backward direction. So we think of it as negative, having a negative velocity. But it would still have, but the speed, the scalar quantity, would be the same. Now, when we talk about the magnitude of a vector, we put these two lines. That magnitude of the velocity will be denoted with this, and that is equal to the speed. And the speed is the same in this instance in either direction. Now let's think of a little example to think about both velocity, distance and displacement. So we've got a runner, and he is on a track. The distance of the full track is 40 metres. This is the origin, and this is plus 20 from the origin, 20 metres, and this is minus 20 metres from the origin. That's the displacement. This is the positive direction, so we define what is the positive and what's the negative direction. Now let's think, if our runner is here, we say his speed is plus 4 metres per second. He is 10 metres away from the origin, and his displacement is 10 metres. So now our wee man is still running. Here's our origin, but now he's still at the same point as he was before, but this time he has ran to the end and he's on his way back. So let's think, what is his displacement? So he's went plus 20, but now he's running in the negative direction, so he's now went minus 10 metres away back. So his total displacement is still 10 metres, although his distance that he's ran is 20, 30. He's run a distance of 30 metres, but his displacement is 10. And now his speed is minus 4 metres per second. Now he goes past his origin, and now he's here. Now he's a distance of 10 metres away from the origin in the opposite direction. So he's ran all the way up here, all the way down, he's now here. He's still running in this direction, so his velocity is still minus 4 meters per second. And this time his displacement is, so he's done his plus 20, but then he's went plus 20 to here, then he's went in the negative direction, so he's done negative 20, then he's got to here, and then he's done negative 10, so his total displacement is minus 10 meters. Now he's on his way back. So, I should say as well, so his displacement is negative 10, but the distance he's ran is 20, 40, 50. Now, he is still 10 meters away from the origin. This time he's ran up here, he's ran down, and now he's running back. So now his velocity is plus 4, and his displacement, let's put that for displacement, so he's done plus 20, minus 20, there it is, plus 20, that direction, minus 20, then another minus 20 down here, and then he's done plus 10, so his total displacement is minus 10. And when he comes back to the origin, his displacement will be 0 because he's ran the circuit back to his starting position. And now, but his distance at this point is 20, 40, 60, 70. So his distance at this point is 70 meters, but his displacement is minus 10 meters. No. So the average velocity is equal to the net change in displacement over total time. So we think of it as V over S, total displacement over T. This is a key formula which we need to remember, and we can use it as with vectors, velocity and displacement, but we could also use it for speed and distance. For velocity, we measure velocity in meters per second. It's the SI units. When you're looking at questions, be careful if they're in kilometers per hour or miles per hour to make sure that you are working in the correct units. Let's think of a problem. So a car travels 9 kilometers in 15 minutes at a constant speed. Find the speed in meters per second. So 9 kilometers is 9,000 meters, and the speed 15 minutes is going to be 15 times 60 is going to be 900 seconds. And so we're now going to use our formula V equals S over T, rearranging it, S equals, sorry, to rearrange it. So the distance is 9,000 over 900, so the speed is going to be 10 meters per second. Let's do another one. A cyclist travels at 5 meters per second for 30 seconds. Then turns back, travelling at 3 meters per second for 10 seconds. Find her displacement from in the original direction of motion from our starting point. So, if you think of our starting points here, the cyclist travels at a speed of 5 meters per second for 30 seconds, so T 30 seconds. Oops, 30 seconds. Then she turns back and is travelling at 3 meters per second for 10 seconds. So S equals VT. So in the first instance, how far does she travel in 30 seconds? So 5 times 30 equals 150 meters. So she's gone 150 meters in those first 30 seconds. Now, so that's S1. S2 is going to be minus 3, which is in the opposite direction, times 10, which is minus 30 meters. So the distance that she ends up is going to be 150 plus minus 30, which is 120 meters. So from here to here, just where is the distance she is from her original starting point. Now a cyclist spends, so let's think of another one, a cyclist again spends some of his journey going downhill at 50 meters per second. And the rest of his time going uphill. At 5 meters per second. In 1 minute, he travels 540 meters. Find how long he spent going downhill. So let's think. So he's downhill, then he's uphill. He's going downhill at 15 meters per second, and he's going uphill at 5 meters per second, and his distance is 540 meters in 1 minute. So let's say T is the amount of time spent going downhill. 60 minus T equals the time spent going uphill. So the total distance, how far is he going? We know his total distance has been 540. So let's think about, we know that S is V times T. We know his total distance and we know the velocity for each part of his journey. So it's going to be, the total distance will be V1 for his first part plus V2 plus the second part of his journey V2, T2. But we know that T2, the time going uphill, is the same as 60 take away the time going uphill. So total distance is 540. The velocity V1 is 15, and we've called T1 just T, plus the velocity going uphill is 5, and this is the same as this, so we're going to put that in instead. Because what we're trying to do is create a formula that's only got one variable. When we've got one variable, we can solve it. So let's expand the bracket. 5 times 60 is 300 T, no T, sorry, minus 5T. So now we're going to bring the 300 over here, so it's going to be 240 equals 15T minus 5T is 10T. So T must equal 24 seconds. Now, it's really important when you're doing these types of questions to think about if your answer makes sense. This answer makes sense. It makes sense that you could be cycling downhill for 24 seconds. Always look at the question, look at what you get, and if it's sensible, these are going to be the kind of questions that are going to be that will be taken from real life. So ask yourself, does my answer make sense? Or is it physically possible? If you get a negative where it should be a positive, for example, you might have gone wrong. So yeah, really ask yourself these questions when you're doing these sorts of questions, and it'll help you.